Okie dokie, for topic 5, we need to remember the theorem that showed us that if we have two chords that are equidistant from the center, they have to be the same length. We went over that, like weeks ago. So that means D to C has to be the same size as C to B. It says that my arc for DC is 12x plus 7. And my arc from C to B is 18 minus 23, or 18x minus 23. We're told that we're supposed to find the arc DAB. I can't do that until I know how many degrees these two arcs take up down at the bottom. So let's figure out their size. We know they're equal. If we know they're equal, we can make an equation equal. So 12x plus 7 equals 18x minus 23. That looks bad. Cool. Love it. 12x plus 7, is that what it is? Yep. So let's solve for x. I'm going to subtract 12x from both sides and add 23. So I'm getting 30 equals 6x. So my x is 5. But I'm supposed to figure out how big this arc is. So if my arc out here plus these two equal 360, well, I better plug x in for 5. I like multiplying 5 times 12 better than 5 times 18, so I'm going to plug that in here. 5 times 12 is 60. So the arc DC is the length of whatever 12 times 5, which is 60, plus 7, which is 67 degrees. So if DC is 67 degrees, so is CB. So I'm saying my arc DAB is whatever the entire circle is without 67 twice. 360 minus 67 minus 67. 226 degrees. And that's my answer. Number 12. If GP equals PH, hey, those are my initials. GA, oh wait, I can't just read it and not look at the diagram. G to P, where is that? Oh, it's right here. Okay, if that's equal to pH, oh good. Why is that so important? Because now we know that the chord DB must be congruent to the chord EA. Also, they tell us that GA is 17. Okay, I gotta get in there. Label this 17. Okay. ED is 37 degrees. Man, they're making us work hard for this answer. 37 degrees. And we haven't even finished reading it. The measure from A to B is 87 degrees. Okay, I can do that. I can do that. I'm just filling in. Just trucking. Find each measure. Ah, all of those. Criminy. Well, it's okay. Because I'm going to look here. I know 87 and 36 are taken care of. And then I know that this arc and this arc have to be the same. And that accounts for everything around the outside. So let's take 360 degrees. Let's get rid of that 87 that we already accounted for and the 37. That's 236 degrees. And then we know that arc DB and EA, this guy and this guy, are the same. So let's divide that exactly in 2. And I get 118 degrees. I don't even know if we need to define that. Let's hope we did. Do we need EA or DB? Yes, we do. It's right here, 118 degrees. Cool. DB wants a length. Oh, that's okay, because look, if this is 17, this part right here, this also has to be 17, and that's perfect because this and this have to be the same length. Ah, we got it. DB is equal to the length of AB. And if that part's 17, then this part is, ooh, that's a highlighter. If this is also 17, that means from A to E, all the way across, is whatever 17 plus 17 is, which is totally 34. So DB is also 34 units across. I'm going to erase some of this stuff because now it's getting really crowded up in here. Okay, so we got those two. EG. Oh, that's good because these two have to be the same length also. That's perfect because, back in that theorem from a couple of weeks ago, it did say that this radius has to be a perpendicular bisector. So that's how I know that. EG has to be the same length. So this one is 17. F to A, again, perpendicular bisector. So it's going to be half the length of that arc. We know that the arc from E to A total is the same as the arc from D to B, which we already found. If this entire thing is 118, half of that is 59. Yep, so let's do 59 here. CD. Ah, same thing. Haha! You guys, we rocked it. It's so good. F to A, C to D. Man, I couldn't be prouder. We're doing great. Also, what topic was this? Does anybody know? Okay, that was topic 5. Wow, we're trucking. We're trucking.